Okay, in this video, we're going to go over the basics of writing and running computer programs in Java. We're doing this because the method that they use in your book, which is to use an editor called Dr. Java, is a little bit outdated. So in this class, we'll be using a different editor and a slightly different procedure in order to write and run our Java programs. I'm going to demo this on my machine, which is a Windows machine. But in general, you'll be working on the lab machines, either directly in the lab or remotely. The process is more or less the same, but we recommend that you don't work on your own machine, but you have a remote connection to the lab instead. All right, so let's get started. The basics of writing a program involve writing the code, which is to create a file that has the instructions that you want the computer to execute in it. And you can do that using something called a text editor. Now, a text editor is just a program that allows you to type and has nice properties and behaviors for typing code. So you can see, here's my text editor. This is a text editor called Atom, A-T-O-M, and we're going to be using Atom as our text editor, recommended text editor for this class. Now you can use any text editor that you want. You may have heard of an editor called Vim. Lots of people use that. That's available on the lab machines. It has a slightly steeper learning curve than Atom. So we recommend that you use Atom. It's a professional editor. People use it in industry, and it's a pretty good way to get started because it's pretty friendly. So we're going to create our first Java class using the text editor Atom. And here it is. So you can see that I've already written this class, and it has a number of different components. So these first lines at the top, these are called comments. They start with a // You can also create comments that start with a /* and then have to be closed with another */. That will create a comment. Or sometimes you'll see a comment with a /**. And this is a special kind of comment called a JavaDoc comment. We won't get into this in much detail right now, but we'll talk about that a little bit later this quarter. So anything that starts with a /* up until the next */ or a /** up until a */ or just a // until the end of the line, that's a comment. That's information for the programmer. The Java compiler, which we'll talk about in a second, will ignore those lines. So those mean nothing in terms of what the program does. They're just notes to ourselves and to other programmers. The actual program starts here on line 7. This line here that says public class first demo. Now, there's a lot in Java that's going to be a little bit magical at first, and I'm going to ask you to just go with me and trust me that by the end of this quarter, you'll understand all the different details about creating a Java class. But basically what you need to know is that this line, public class, and then the name of the class, I've chosen to call this class first demo, is what needs to start every class in Java. We're declaring that we're creating a new class, which is how we run our code. Then we have this open brace, which says everything after this open brace up until the matching close brace is part of this class. Okay, so there's not too much in this class. There's just one, what's called a method, and that's right here on line 9. It says public static void main, open paren, string, open bracket, close bracket, and then args, close paren. This will look like magic. That's okay. Later on, we're going to talk about what each of those words mean. But what you need to know is that this line is always going to look the same, no matter what program you're writing, and it's always where the program starts executing. So the program will begin its execution with main. So here's where it starts. There might be some more code up here, there might be some more code down here, but the program will always start executing in the main method. Okay, so here's main, and now inside of main we can see what we have. We have 4 lines of code. 1, 2, 3, 4. Lines 10, 11, 12, and 13. And each of these lines start with this little incantation that says system.out.println. And that's an instruction that's built into Java, and it's telling Java that we want to print something out to the console. So when we run it, Java's going to print this. So what is this? This is 34 plus 56. And what Java's actually going to do is it's not going to print literally 34 plus 56. It's going to print the result of calculating 34 plus 56. So we can see how Java will interpret what's called the argument to the system.out.println, because these are numbers that we're asking Java to do some arithmetic with. So you can take a look at this code and you can kind of predict what you think this is going to print to the screen when we run the program. And we're going to do that in just a second. All right, so main, it'll start executing in main, but how do we actually get this code to run? Well, first we need to save our file, and I've already done that. And if you look up here, it's kind of small, you can see that I've saved it to a file called firstdemo.java, and that's required. You have to have the name of the file, firstdemo.java, must be the same as the name of the class that I'm declaring. So you see my class is called firstdemo, and the file needs to be called firstdemo.java. That's just something Java requires. Notice that the capitalization, and we're not allowed to have spaces, but the capitalization has to be exactly the same. So here I have capital F, capital D, everything else is lowercase. Up here in the name of the file, I have capital F, capital D, everything else is lowercase, and then .java. Java is very persnickety about case. You have to be careful about what's uppercase and what's lowercase. It treats those two things differently. Okay, so then now we're ready to run our program. Running our program is a two-stage process in Java. So we're going to go over here to something called the terminal window. Now I'm using a program called Cygwin, and that's a terminal simulator. It will simulate the Unix shell that you'll be working with on the lab machines. Don't worry if you don't understand what I just said. Just go to the window that's called the terminal, and the lab will help step you through this process. And now first we need to get to the location where that Java file is located. So I'm in the directory called Winter 2018. And I can see that here because this little line here is telling me what directory I'm in. So I'm in the directory Winter 2018. But if I go over here and look at the header up here, I see that my file is actually inside a subdirectory called Class Demos and Examples. And I can find that directory by typing a command called ls. ls is going to tell me what is in the directory that I'm currently in. What's a directory? A directory is just like a folder on your computer that stores different files. It's a way to organize your files. And what we've just created in Atom is a file. It's a file containing Java code. So we need to go to the place where that file is located. So I'll type ls, and I'll see that, aha, one of the subdirectories, one of the folders inside the directory I'm currently in is called Class Demos and Examples. So I need to now change directories using a command called cd for change directory into the directory Class Demos and Examples. And I can just type a couple characters, CLAS, and then what I did was I hit the tab character, and that whole thing just expanded for me. That's just a handy little shortcut that you can use in the labs as well. So I'll do that. And now you can see that my path has changed, and now I'm here in the Class Demos and Example folder. And if I do ls, which again is to list the contents of the directory, I will see that now I see this firstdemo.java file. Now, I also see a file called firstdemo.class. That's actually what's going to be produced when I run the Java-C or the compiler on my firstdemo.java. So let me actually run that for you. So our first step in running our Java program is to compile the Java program. The compilation process translates my Java code, which is what I just wrote in my Atom editor, into some instructions that the machine can understand, which is what's going to be in this .class file. So I say Java-C, that's the name of the compiler, and then I give it the name of the file I want to compile, firstdemo.java, and hit enter, and if all goes well, we see nothing. What we actually do see is that this firstdemo.class file should get created. It was already there, but it will be replaced by what I just did. All right, so that's all done. And now I'm going to run my program by saying Java, so not Java-C, this is not the compiler anymore, this is actually running the program. So Java first demo. Now notice that when I'm running Java, I no longer need to include the what's called extension or the dot and then the information after the dot. Because Java knows that if this is going to be run, there must be a .class version of this file. And so we'll look for that .class version and execute it. So let's see what happens when I run that. All right, when I run it, I get what I expect. I get the results of each of those arithmetic expressions printed out to the screen on a separate line. That's what that system.out.println will do. Okay, so let's now go back and I'll show you some little sort of gotchas when you're compiling and running your programs. The first thing is that Java is very sensitive about some things, but not so sensitive about others. So one thing people ask about is, do these spaces matter? Is it important that I have spaces between the plus? And the answer to that is no. I can take away these spaces, save my file, compile my file. By the way, if you're wondering how I'm doing this so quickly, getting back to previous commands, I'm using the up arrow, which will scroll through the previous commands that I've executed. So I go 2 commands back, recompile my file, and see that it recompiles just fine. And if I run it, I see that it does the exact same thing. However, there are some things that Java is really persnickety about. For example, capitalization. If I change the capitalization here, instead of first demo, I make it first demo with a little d, and then I try to compile it, you can see that I get an error. So this is called the compile error. It's saying first demo is public, and it should be declared in a file named firstdemo.java, but my file is actually called firstdemo with a capital D.java, which is not the same thing, and that's why I'm getting that error there. So really picky about some things, really not so picky about others, and it's just a matter of learning the language to know which of these things are important and which of these things are not. I like to include the spaces after the plus and before the plus for readability. The other thing that Java is persnickety about are these open and close braces. So for every block of code that you write, you need to have an open brace and then a matching close brace. Java is also uptight about semicolons. So if I get rid of one of these semicolons, and I save my file, and I go back and try to recompile it, we can see it won't compile, and it's telling me that it expects to see a semicolon at the end of the line. That's because every statement in Java has to end with a semicolon, and if I forget, I'll get an error. All right. The last couple things I want to talk to you about, one is I want to tell you about the different kinds of data that we can work with in Java. Now, we're going to be working with this a lot, exploring this in much more detail, so this is just a first taste of how data can be different depending on what type it is. So we saw that when I say system.out.println 34 plus 56, I actually printed out the result of executing the expression 34 plus 56, and I got 90. But what if I actually literally wanted to print out the expression 34 plus 56? I could do that, but I would need to change the type of data that I'm printing out. Instead of having 2 integers added together, I can enclose those integers in double quotes, and this will create, instead of numbers, what's called a string. So now that I have passing a string to the println function, I get a very different behavior. So I can now save that file, compile it, and it compiles fine, and then I'll run it again. And I can see that rather than telling me that it prints 90, it will print out literally 34 plus 56, if that's what I wanted to do. So there's a difference between strings, which are what are inside those double quotes, and numbers, which are just these plain numbers on the screen. I can even mix the two. So if I want to make an expression like 34 plus 56 equals, and then I actually want to print out what it equals, I can use the plus sign to combine this string with the result of this expression, which I'll put in parentheses so that it will actually calculate it and not be unhappy. And then I can compile that and see what it does. And you can see that now I have the string part, the 34 plus 56 equals, and then the result of executing 34 plus 56. So that's kind of a way how I can combine strings and numbers in one expression. Now we're going to be talking a lot more about data and data types throughout this course and coming up right away in these first couple weeks. So don't worry if this is going a little too fast. But for now, I just wanted you to get a sense of the basics of creating a Java class, writing some instructions, compiling that class, and running the program. And that's how you're going to get started with Java.